So now that we've practiced taking nth roots, we want to bring something else into the mix. We want to go ahead and talk about those rational exponents, and we want to be able to move back and forth between our radical form and our exponent form. So let's take a look at some equivalent expressions. If we have a raised to the m over n power, we can break that into two pieces using our product or power of a power property. So we could say that it's a to the 1 over n power raised to the m power. Well, we already know that a to the 1 over n power can be rewritten in radical form as the nth root of a. So we can take the nth root of a and raise it to the m power. We also don't actually need the parentheses here. We could simply write n in front as our index. This is known as the index. And we could write our m as the power that we're raising a to. So that can be underneath the radical, or it could be outside the radical out here, or like it is here in parentheses, or outside of parentheses. So any of those are interchangeable, and we want to use this information to move back and forth from rational exponent form to radical form. So in examples 3 through 5, we want to change from our rational exponent form to radical form, but then we also want to evaluate this and see if we can just get rid of exponents and radicals and all of that all together. So here's our example number 3. We have 16 raised to the 3 over 2 power. So we could rewrite this in radical form if we're asked to do so, and you will be asked to do this in some of your homework problems, as 16 as our base, 2 as our index, and raise that to the 3rd power. Well, remember that we don't necessarily always, or we don't usually write the 2 there. It's implied as a square root if nothing is written there. So we don't technically need to write the 2, but I did in this case because I really want to show you where each of these numbers is going. The 2 goes in the front, the 3 goes in the back. We could rewrite this in this form without the parentheses, but it really doesn't matter. What I want to do from here is go ahead and start evaluating. And you can put this entire thing into Desmos Scientific Calculator or into your regular calculator, or we can do it in pieces. And if we do it in pieces, I think you'll see that we could even do some of this without a calculator. So we know what the square root of 16 is. We know that the square root of 16 is 4. So we could say that we really have 4 raised to the 3rd power. So 4 times 4 is 16, and then times another 4 is equal to 64. But I want to show you that you can put this in Desmos if you don't want to do your mental math. Here we are in Desmos, and we want to take the 2nd root of 16 and then raise that to the 3rd power. So we could either use the nth root, or we could simply use the square root since we know that our index is 2. I'm going to go ahead and be consistent with what we've been doing and do the nth root and put a 2 here. 16 goes underneath, and then that 3 could just be here with the 16 under the radical. We saw that that was one of our forms, so I'm going to say my a raised to the b power, my a is 16, and my b is going to be 3. And notice that this gives us an answer of 64. All right, so the calculator gave us the same answer that we did using our mental math, and so we know that our answer is 64. Next, let's do 32 raised to the negative 3/5 power. So the first thing I notice is that I have a negative exponent, and anytime I have a negative exponent, I want to get rid of that by using my negative exponent property. So it's going to be 1 over the thing that's raised to the negative exponent, which is 32, and my exponent becomes positive. From here, I could rewrite this in radical form if I'm asked to do so, and I want you to practice doing this because you'll have to do that on some of your homework problems. So I can say that it's 1 over, and then do the 5th root of 32 and raise that to the 3rd power. Notice that this time I didn't bother putting the parentheses in there, and you don't have to do it, but you can if you want. All right, so now we want to evaluate the 5th root of 32 and raise that to the 3rd power. We can evaluate this using our mental math and doing this in our head, or we can use Desmos. So I'm going to show you how to do this with just evaluating in your head, and then we will move to Desmos. So we want to think of something that multiplied by itself 5 times will give me 32. And that's going to be a 2, because 2 multiplied by itself 5 times is 32. So the 5th root of 32 is 2, and we're going to raise that to the 3rd power. Well, 2 times 2 times 2 is 8, so this ends up being 1 over 8. Let's check our math in Desmos. Here we are in Desmos, and we want to go ahead and put in our fraction that we had. So the first thing I'll do is use the fraction over on the right hand side, the a over b. My top number is 1, and then on the bottom is where I'm going to have my rational exponent, or in this case we're going to use our radical form. So I'm going to say 5th root of 32, and again, this could be either on the inside or the outside of the radical. It actually doesn't make a difference. 32 raised to the 3rd power. And you can see that it says 0.125. We don't want decimals, we want fractions, so hit the fraction key that's right next to that decimal, and that's going to change it. So just hit this button, and that'll change it back and forth from a fraction to a decimal. We want the 1/8, which is the same thing that we already reported using our mental math in our notes. All right, I would like you to try number 5 on your own. Write it in radical form first, and then evaluate it and simplify it as much as you can. Come back here to see how you did. All right, so what you should have done is put a 3 as your index, and then the 27 is our base. The exponent is 2. Remember that this could be in parentheses or not. It really doesn't matter either way. The first thing that I did using mental math is I said, what is the 3rd root of 27? Well, 3 times 3 times 3 gives me 27. So the 3rd root of 27 is 3. And I need to square 3 and get 9. But of course, you could have put this entire thing into Desmos and gotten that as well.